Welcome everybody to the Young Scientists, the Young African Scientists platform. We are going to have another machine learning session. Today we are having a machine learning project that you're going to go through on your own and replicate some of the graphs that will be done in this session. And when you turn that in, then you get a certificate of competence in addition to the certificate of achievement that we are going to give everyone. The teacher that is going to take us through this remains Elvis Chumesi. So Dr. Elvis Chumesi, if you're with us, you can turn your slides on and your camera on preferably, and then you can start the session. So Dr. Elvis, please share your slides and come on board.
Okay, thank you very much. And we are all welcome to the Young African Scientists. And today, as we have already described, we are ending the session. And basically, it's about projects, right? So basically, we are going to go through coding, basically to embark on the project. And after I go through the project with you, I'll give you the same project so that you go back and go and implement it by yourself. Basically, that's how everything is just going to be like. So, from the beginning of the class, we shared that we are going to embark on a project at the end of the day. So we have gone through almost a lot of topics. I remember I introduced machine learning. We spoke about how to clean your data. We also spoke about the evaluation metrics. We also spoke about, I think I also came in, also taught about convolutional neural network, how to detect images, classify images, and all those things. But this project, I just want to keep it as simple as possible so that we will all follow how we go about the project. And when we are done, you go back and implement the same project in a very simple way. So basically, that's how everything is going to be. So we are just going straight to Google Colab and work on a sample project. And then at the end of the day, we all go and implement the project by ourselves also. Yes. Okay, so I don't know. I'm sure you have your laptops with you that you would want to follow me throughout the entire process because we just want to go through a sample project so that when you get a project that you want to embark on, you can do it by yourself at the end of the day. Okay, so let's just have a quick recap on the things we know already, right? I think we introduced you to Jupyter Notebook. And then we told you that when you are dealing with Python, we have Python as the software mainly, but then we have some interfaces that you have to work on in terms of your code and all. So we have something called Jupyter Notebook. We have something called Google Colab. We have something called Visual Studio Code. And I think throughout the classes, we've used almost all of them. I think one point someone used VS Code. One time somebody used Jupyter Notebook. One time someone also used Google Colab. I want us to use Google Colab today because Google Colab is just like the Jupyter Notebook we made all of you install, right? And let me share my screen quickly. Okay. Let me get it this way. Good. And I'm sure you can see my screen now. Yeah, so with Google Colab, I'm sure you can, if you don't have, one thing I like about Google Colab is that you don't need to do plenty installation. Just go online to your, just for those maybe who didn't join us from the beginning and everything, so that we can go through everything together. So with Google Colab, you don't need to go through all the plenty installation process. You have to download Anaconda and go to Jupyter Notebook and all, because you can just go to your web browser and just type this collab.research.google.com, and then you have an interface like this opened for you, right? So when you get this interface, you can easily save the file here, and you leave this .ipyn, that's this Python notebook part there, and just name. So here I'm calling this the engine project. You just want to do this so that you can embark on a full project by yourself. Yeah, so with this is the nice thing about it, because one thing is we don't need to install Python, we don't need to go through Anaconda and all those things. We just have a very good interface that we can start working on and everything. Maybe those who just open it for new, when you go to file, you go to new notebook in Drive, you can open the notebook. And one nice thing about Google Colab is that whilst you are working, everything will be saved within your Google Drive already. So even if you miss to save it, it then need to be saved for you to get access to it anytime. So that's one nice thing why I want us to. So the same thing, the cells here are already there. If you want to add more cells, you can add more cells. And then if you want to comment out your cell, you can add a text. So these code cells are mainly for coding. You can write your code within. But if you want to maybe describe some of the things that we are doing, so let me just move this thing here and move this to the top. If you want to move maybe one cell to the top, you can easily do that. So I just want to write in here like engine projects. So here I'm using this tests, right, so that I can write. So here, what it means that when I run the code, that place is not going to run it, because it's basically going to be a cell, right? So how to, you just want to look at engine projects like the that we are doing, how to conduct a simple project. So now let's say you have anything depending on your field, whether engineering, social science, and everything that you want to do. And today, I want us to deal with a very simple project. I think in the introductory class, we spoke about machine learning, and we talked about the various types that we have: supervised, unsupervised, reinforcement learning, and we spoke about all that. Then we said we are basically going to look at supervised. So we are just going to conduct a project on the supervised learning one. And we said under supervised, we have something called regression model, regression, and then we have something we call the classification. So I just want us to do a small classification project today. Then we can then implement that by yourself, right? After I go through everything, you can have the video and everything, and then you can go through step by step and then do the coding by yourself and resubmit everything to us by just adding some few lines or one or two things, and then we are good to go. Good. Now, one thing that you need to do, especially when you are conducting any project, and the project I actually want us to conduct is, I have some data here. Let me see if I can get that to the screen. Hello, can you see my screen? What do you see? I, can you see the data I've shared?
Curriculum.
Okay, still see collab. Okay, let me just stop sharing here. And then, okay. So I have a simple project here I want us to look at. So let's say, for instance, you are in a manufacturing industry, and then you have gathered some data about maybe a certain machine that works, right? Uh, and then you want to conduct some machine learning work with respect to the. So let's say, for instance, you have a CNC machine, you have various machines within your industry, and then you have some sensors that you have been able to measure the temperature of the machine whilst working at every time stamp, and then you have the speed of the machine. Maybe like we are talking about any rotating machine, right? This data was actually provided for smart manufacturing, right? So that if, let's say, you want to have a very smart manufacturing process within your industry where you have some various machines like CNC and all that, where you have some sensors measuring the temperature of the device, and then you have measuring the speed of the device, and then every machine, maybe all the hole you cut and then all the cutting you do, there's a score that you give to the quality of the production line. At the end of the day, what comes out, you have a score that you give to that, maybe in terms of from 0 to 10 or something. Then the vibration level of the machine, you have that, maybe a sensor also measuring that, how much energy is consuming. And at the end of the day, when depending on the temperature, speed, and the quality, vibration, and the energy is consuming, maybe you are aware whether the product that you got at the end of the manufacturing process failed or did not fail. So here we are using 0 to represent failed manufacturing process, and then 1 to represent at the end of the day the thing passed right through the manufacturing process. So just like a simple system, you have a machine. You were able to get some sensors on the machine. You've been able to monitor the temperature, the speed, and everything. And at the end of the day, depending on the conditions, you are able to tell. You are like as in throughout the manufacturing process, you are able to tell whether the thing failed or did not fail, right? So you know that this time when the speed was this and then the temperature was this, when you went through the production line, the thing didn't fail. Then you say, okay, you measured this and this and this is 0. Then another time you measure this and this is 1, and all that. So you've been able to gather a number of data. Then I have some data sets here, which is about 10,000 data sets, which were conducted in a timestamp manner, where we measure the temperature, the speed, and all that of a manufacturing process. And we are able to tell whether the thing will fail or not. So let's say you have such a project at your disposal, and you want to use machine learning to predict the next time if the temperature is this and the machine speed is this and the quality is this, then are you going, is the outcome going to be a failed product, or is going to be a product that will pass the test of everything that you are doing? So basically, we want to conduct such a simple project. And from our understanding so far, we know that if I want to predict whether something will fail or not fail, then we are doing classification. So I want us to do some simple classification work within this work. And when we finish, then I'll give you this same data. Then what you go and do is, as an example, just go and take the same data and rather predict the quality score of the product, right? The quality score, whether at the end of the day, what you produce, will it be quality or it will not be quality, right? How well or how much score will you get in terms of its quality, right? So in that case, you will switch it to a regression work, right? But basically, you go through this classification and then you go back and then implement the same classification. And if there need be, you add on for you to turn everything to a regression work. And if you know what you are doing, it's not any big deal to do that thing, right? Good one. So this is the data that we have. So basically, we know that this is going to be our target. We spoke about features and target. So our target is what we want to do. We want to know the optimal condition. Did it fail or it didn't fail, right? And we are using 0 for fail, 1 for pass. So you know that this column at the last point here is your target. So what it means that all the other things, temperature, machine, production quality, and all that, you have all these as your features, right? So first of all, as soon as you gather your data, and I didn't want us to go through a long process, because some of the time, some of these data that you have gathered, maybe the sensor, instead of measuring this temperature can be missing, right? So maybe that time the temperature sensor was not working. So because of that, I wasn't able to measure the temperature. So some places may be open, or let's say empty, that you would have to go through the cleaning process that we learned in machine learning to be able to fill in within the data and all that. But just for this simple project, we just assume that we have a very good data, clean data already, everything is fine. So we want to just conduct a machine learning work on that, right? So let's go with that. So we know we are doing classification, number one. Number two, we know our target is this last column, and our features. The features are the things that help us predict the target, right? And we know that temperature, speed, quality, vibration level, and energy consumption are the things that we are going to, are the features that we are going to use to predict that. So we bear all these things in mind, and then that's what we are going to have in mind in the machine learning process. Good. So let me go back to the collab, and then with this idea that we are going to go through the machine learning process with this idea in terms of coding. Good.
All right, Elvis, can you share the document with us so that those that
Okay, so let me do that. Let me just put the document on the page now. Then we all follow.
All right, whilst Dr. Elvis is trying to share the document with us, attendance today is very important. So if you are here, please take a minute to mark your attendance for today, because we're going to use this to issue out the certificate of competence when it's ready. So please make sure you have marked your attendance. And then I also made an announcement that from next year, we are going to have different workshops for different people. It won't just be machine learning for everyone. We are going to have different seminars and workshops for the different thematic areas that we have in the group. Everybody has registered, so we know your backgrounds and we know where you are. So we will organize based on the registration, organize different workshops for different people. And as and when it is ready, we'll deliver that, and we'll put the schedule ahead of time, so you know when the workshops will be held. And we are going to put the areas that are going to be handled under those workshops as well. Now, all our meetings and our workshops from today are going to have certificates. So if you attend any of our meetings, you're going to have a micro credential that says that you have attended this lecture, and you can add it to your documentation when you're applying for a job, especially in those areas. And so this is going to give you an opportunity to be able to have things like that and add it to your professional documentation. Dr. Evans, we are still waiting for you, so whenever you come back, then you can take over. If you send the document to me, I will post it as well.
Yes, please. So you can check your Sunni mail.
Okay.
You should reflect now.
Yeah, so you go ahead. When I receive it, I'll share it.
Sure. Okay, good. So let's start, and we are just going to go through line by line so that you'll be able to follow everything in a simple manner. Now, the first thing that you need to do, especially when you are conducting any machine learning work, is number one, you need to import libraries, right? Now, libraries, so let me just get a title here and call it libraries. Okay, let me just deal away with this one. And you see, one thing is that this cell is a code cell. So if you want to have any comment in, you have to put this hashtag sign so that when you run the code, that part will not also run, right? So let me put that and say libraries. You are following through to be good if you are having your laptop and you are following with because it's just going to be a simple way. Then you'll be able to know what you're actually doing. Now, I like Collab because most of the time when you're even using it, you get some suggested way to go about it and things become a little shorter for you. Now, we have libraries. Now, what are libraries? Libraries are, I would say that they are just things that, just like go to the library, you go to a library, you have people who have written books that are there that can help you do some of the things you have to do without you suffering, right? So a lot of people are provided libraries for machine learning so that I can easily work on machine learning work, so that you work on machine learning projects without trying to code everything from scratch, right? So one there are some key things you need to some key libraries that you need for every machine learning work. Now, the first one is something we call pandas, right? So pandas it actually helps you, especially when you are dealing with data and you want the data, especially we have CSV files, Excel files, and you need it in a very structured manner, right? So every time we need to import uh, this library that people have already designed to help you, because the thing is that we have the Excel data there. And we're actually going to use that Excel data, uh, Excel or CSV data, and we are going to conduct machine learning on that. So we need something that we can use to read that file, and we don't need to write a code from scratch on how to read the file. Pandas and NumPy and all those things are able to help us with that one, right? So you have to import this pandas library. Now we realize that if you are using VS Code and some of the other IDEs and all that, you need to install these libraries, right? You need to install these libraries. But one thing about Google Colab is that all these libraries, all the important libraries, the one that you actually need for basic machine learning, everything has already been installed at the background for you. So we don't need to install them now. Everything is there, unless maybe you are dealing with some high class machine learning works and you need some libraries that is already not in Google Colab that you have to pip install it in the process of your machine learning. So something like pandas and most of the machine learning things you are going to use are already there. Now, mostly we import pandas and then we just give it a shortcut called PD, right? So one thing I like is, you see, as I wrote import pandas, I get some suggestion like, okay, as PD and all that. And basically, I want us to also import NumPy. NumPy is able to help us deal with more numbers. We want to import NumPy as NP, right? So these are basic libraries that will help you, especially with uploading your data and dealing with numbers and everything, right? Now, the next thing that you need to do is to import some libraries from something we call scikit-learn, right? Scikit-learn, or we call it sklearn, just to have a short one, sklearn. Now, scikit-learn, as we went through the machine learning works, we introduced you to there are different libraries that people have built to deal with machine learning work. We have scikit-learn, we have TensorFlow, we have PyTorch, right? And most of the time when you're dealing with basic machine learning work like this work that we are going to do, scikit-learn has provided libraries that makes work easier and coding easier for you, especially when you are dealing with machine learning, basic machine learning work. We are dealing with deep learning works, then you may need something we call PyTorch or TensorFlow with Keras, and it will make your work. And if you remember when we're dealing with convolutional neural network, I was using TensorFlow with Keras for us to use for that. But this is basic work. So we are going to use something we call sklearn. Now, sklearn, scikit-learn, because it's mainly for machine learning work, almost all the things about machine learning are already programmed in this sklearn. So what it means is that we have to, and Google Colab already have this sklearn installed. So most of the time, what you need to do is just say from sklearn, right? sklearn dot model selection. So sklearn has a lot of models inside it, right? So we want to select some particular models that you will need for your work that you want to do. And if you remember your machine learning work, since we have our data, what we are going to do with the data is that we are going to split the data. So all your understanding of all the things that we have taught will be the one to tell you which libraries you need to import at the beginning of your machine learning work. So I know that I'm going to import my data, and with the importation of my data, this pandas is going to help me. So I start with it. It doesn't matter which one you start with, right? The next thing is that I know I'm going to, after I've imported the data, I'm going to choose which one am I going to use as the features and which one am I going to use as the targets. So at least NumPy, Pandas is going to help me decide which one is my features, which one is my targets. Then after I know my features and targets, the data that I have about 10,000 data sets. I want to split them. So I will need something we call the train test splits. This train test splits is already a library by sklearn in scikit-learn that is able to help you split data, right? So we just want to say from sklearn models, or sklearn has a lot of models, right? So we want to import this train test splits. We want to import this train test split. So you import this train test split, means that the time that you want to split the data, you're going to use this train test split. Nice one. The next thing that I'm going to do is that, after splitting the data, we said that the next thing that I have to do is that I need to scale the data, right? We said that most of the time, machine learning, you realize that we are dealing with speed. Maybe this one will be in 1,000 revolution per second and all that. Then we have the product quality score, which is a number between maybe number between 0 to 1 or something, and realize that some numbers are between 0 to 1, some numbers are in the thousands. So if you are working with them with machine learning, most of the time, machine learning finds it very difficult to deal with such data. So what you mostly do is that you would want to scale all the data between 0 and 1 so that you have all the data within 0 and 1, and then make the machine learning understand the data very well in terms of its prediction. So the same way, this sklearn have provided a pre-processing tool to help us do the pre-processing in terms of scaling. So I'll say from sklearn.preprocessing, right? From sklearn.preprocessing, I want to import something we call the standard scaler. Good. So this standard scaler is a model that will do the scaling for you so that you don't need to go through the 10,000 data set and be doing scale, one by one. This standard scaler will be the one to do it for us in a simple way. The next thing that we are going to do is that we need to import after scaling, then we need to get the models to come and we need to get the various models that we are going to use to try to make the predictions, right? We are going to get the various models that we are going to use for the prediction. So what we are going to do is that we are going to look at from sklearn. From sklearn we want to use models like what? Maybe linear, because we are doing classification, we want to use models like random forest, right? So random forest, we call it an ensemble learning algorithm or model because it's a combination of a lot of decision trees, right? So we'll say that from sklearn.ensemble, right, we are going to import this random forest. And because we are doing classification, you are going to call it random forest classifier. So the same way, if your work was regression, you are going to say import random forest regressor. Good. So here we are going to use a classifier. I'm going to say import random forest classifier. Now, one thing also is that let's say we want to also use which models am I looking at reusing? Maybe we want to also use decision tree or the decision tree. So let's say from sklearn, sklearn.trees, right? So because we want to use decision tree, we say sklearn.tree, want to import this decision tree classifier. we spoke about a lot of models, decision tree, random forest. We have something called k nearest neighbor, right? So let's try k nearest neighbor from sklearn. So k nearest neighbor in sklearn is under something we call neighbors, right? Now the thing is that somebody will say, how will I know that if I need decision trees under tree and if I need random forest under example? You just come with continuous practice and be able to know that if you need k nearest neighbor under sklearn, you get it under neighbors. If you need decision trees under trees, and then if it's you need random forest under ensemble. So when you get to know this, any time that you want to do, you'll be able to do that. Now, as I'm doing this, when I give the assignment, I would want you to add maybe additional 2 models to this, right? So maybe something like support vector machine, something like SGBoost, something like other boost and all that. I will just tell you to add any 2 different classifier that you want, like let's say logistic regression classifier, maybe for you to add that as part of your for you to submit the assignment. So basically, all that you need to know is if I need logistic regression, sklearn, and sklearn, where do I get logistic regression? Then you can then import that logistic regression. So basically,
Elvis,
let's try this. Yes.
your first line, you made it from instead of from.
First line. Okay, good. Thank you. And you realize that all of them are changed, and then this one is not. Thank you. Good. So let's try these 3 classifiers, and then when you get the assignment, I'll let you just add 2 more classifiers to do your work. So realize that I've looked at the one to import, the one to split, the one to do the scaling for me. I've also imported the models that I'm going to use. Another thing I would also want to import is, after you get your model and you fit the models, you make predictions, and then you would want to check whether the predictions you are doing are correct or they are not correct. So you want to use something we call the metrics, right? And then we spoke about various evaluation metrics that you can use when you are doing classification, right? If you remember the various metrics. So we are going to use sklearn under metrics. You want to import the accuracy score, right? You remember accuracy, you remember F1 score, you remember recall, you remember, various ones. And one nice thing is that sklearn has something we call this classification report as a metric, and this classification report, when you call it, it will give you the record, the precision, the accuracy at the same time, right? So every time you can just call this classification report and it will do the record. So you don't need to call for record, you don't need to import record, precision, and all that at the same time. All that you need to call under metrics is this classification report, and it will give you all the reports under that. The last thing I would also want us to import is something we call the confusion matrix, right? You remember the confusion matrix and how we use it in this machine learning work. Now, confusion matrix is also under sklearn.metrics. So it is all under sklearn. So I can just continue this, or you can come to another line and say from sklearn.metrics, import confusion matrix. But I just want to import all of them on the same line, right? Good. So you can do that by just putting the comma. So this has helped us get all the various metrics that we need for our machine learning work. Now, one thing is that after everything, maybe some of these, some of the things, the confusion metrics and all those things, we would want to plot them. We want to have them as plots, right? So we have this library called matplotlib. It's a maths plotting library. So we mostly import it as pyplots, right? As pyplots. Import pyplot as PLT, right? So what it means that if I want to do any plotting, I will not type this whole matplotlib and all that. I'm just going to use PLT to do the plotting, right? And one thing is that this confusion matrix too, we may need it as a heat map, right? So there is this thing called Seaborn. There's this thing called Seaborn that you can also import as SNS. because it can help you. So just like matplotlib, it can just also help you do some different kind of plotting. Matplotlib is basically good for basic scatter plots and bar charts and everything, right? And Seaborn actually help you, especially when you want to plot heat maps like the heat map. The confusion matrix, the way it's drawn, is a heat map. So we use this Seaborn to do that. So we are done with all our libraries. So let's go to the next cell. So just to structure your code well, every time you want to put all the libraries maybe in one cell, then you go to the next cell. So the next cell is where we want to do the next thing. So we've imported all our libraries and we know the processes. So the first thing is to import the data, right? We want to import the data. So how do I import my data? So let's say I want to put my data in a function called df. So what I'm going to do is that I'm going to use the pandas, this PD. I'm going to use it to read. And then the file that we have is a CSV file. I'm sure you've gotten the file and then shared it with them on WhatsApp. So if you want to read a CSV file, you use read underscore CSV, right? Read underscore CSV. And then one thing is that you have to know the name of your data, right? Let's check the name of the data I just sent. Let's do that. Let me just import the data. So most of the time when you go to the files here, when you are dealing with Google Colab, when you go to files here, you can easily import the data that you want to use for the machine learning work. One thing is that you can also import it from your drive, but most of the time, if I'm just doing some work that I'm testing and all, you can just click this part and then import it from your laptop, right? So you have the data stored on your laptop. I have it under download, so I'm just going to double click on it. And then a warning will come to tell you that you have to make sure your data is saved, because when the Google Notebook, when you close your web browser and everything, the data will no more be there, right? So make sure you have the data stored somewhere every time. So just click OK. So this is the data that we are going to use that have the speed, the temperature, and everything all inside this, and we know our target and everything. So here we are going to, and it's a .csv file. Sometimes it can be Excel, right? So in that case, here we would have used read Excel, but here it's a CSV file, so you use read CSV. See, I'm going through step by step in a short way, so that when you pick it, you'll be able to just replicate it for this work, right? Here, we are not just, it's not an exam that we want to test you, want you to, one thing I always say is that now we have a lot of tools to learn and all that. So it's not about cramping things into your head and reproducing and all that. It's about understanding the concept, the steps, so that you can be able to reproduce the things and not just trying to cram things within your head. That's what I'm going through is step by step. Now, this read CSV, you have to make sure you use these two semicolons before you. So realize that I've saved my data as what? Manufacturing. Make sure you use the exact name, because if you don't use the exact name, the data will not be imported. Datasets dot CSV. Good. So when you do this, now let's run our libraries to make sure maybe we've not made any mistake within our libraries. Okay, so that is running. So anytime here ticks, it means that it has run successfully. So the libraries have well been imported. Let's see if we have imported our file well. You see, the file has been imported, because when I ran, I didn't get any error, and it's marked as that. Yes. Let me just do df.head so that we will see whether our data is well imported or not. Good. So you remember that when we were teaching Python, we said you can use, so you see, I've read this file and I've put it within this df. So I'm just saying df.head means it's just give me the first 5 data within the data set, so that I know that it's the right data. You mostly do this just to know it's not part of the code. Just do this to know whether the data that you imported is the exact data that you want to use for the machine learning, just to see, right? So we know we are fine. So let me add another code. So I'm coming here, I'll click for another line to add another code. Now that I've imported my data, the first thing is I have to let the machine learning know which one is my features and which one is my target. So most of the time I use this. So let's say the features, I want to call it X. So I want to say S is equal to, so I want to locate the columns, right? I want to locate the columns. So I'll use df.ilocate, right? I want to locate the columns that have my features, right? So we realize that my features, I want to use all the rules, right? The data should have all the rules. So if you use this bracket, if you use this semicolon, it means all the rules. But then with respect to the column, you see, I want to pick all the columns except the last column. So that's why most of the time for me, I like arranging my data in such a way that the one that is my target is at the last line, so that I don't need to write a lot of line to try to select which ones are my features and which ones are my target. So if you use this, if you use this column -1, it means that you should exclude, the first part here is for the rows and the second part here is for the columns, right? So if you use -1, it means that you should pick all the columns. This one shows you pick all the columns, but you should leave the last column for you, right? Then the next thing is that I want to say why is df.ilocate. Then I want to say that you should pick all the rows, comma, and then you should pick the last column. You see, I didn't bring any semicolon here. I just say -1. It means that I should pick the last column as my target. So now my target is inside this Y, and my features are inside this X.
Yeah, Elvis.
Yes, sir.
There are some questions in there if you want to answer them. So you
Sure.
can go back to where you uploaded the file and just
Okay.
answer some questions for us.
Okay.
So just go back to the command line for the files.
Okay, for the files. Let me close the comments.
Yeah.
Okay, good. Let me just go to the
And then go to the chat.
the charts. Is it from or from? Okay, yeah, we've corrected that. Thank you, Kikun. Okay. What's the difference between import matplotlib as P and then matplot import? The question is almost the same thing. Okay. I'm not seeing any other thing. I don't know whether I can help me with any question that has been. So I think this matplotlib, we've already imported it.
Yeah, you can go ahead then.
Okay. Okay, it's asking whether import matplotlib.pyplot as PLT, and from matplotlib import pyplot. It's the same, right? You can go with them in the same way. Can go with them in the same way. Yeah, can go with them. So let's see that. Yeah. So let's say import matplotlib. Import matplotlib dot pyplot, right? Okay. So you can use the same thing. Good. Everything also runs like that. So thank you. Good. So you can use any. Hey, I hope this thing will misbehave now. Okay, so let's add another. So here we are using that one too. Let's run that. Everything is fine. Let's go to the next code line. And here, after we have known our features and our target, the next thing is that we are going to split our data, right? We are going to split our data. So now we want to just split it as a training set and a testing set, right? There's this validation and all, but because we want to keep the projects as simple as possible, we want to just make everything.
Hello. Hello,
Yes,
Dr.
sir.
Chumesi. Hello.
Yes, sir.
Please, my hand is up for a long time.
Oh, okay, I've not seen it. Sorry.
Yes.
Can't talk.
Please. It seems I'm having a small issue with the file upload. I have
Okay.
added it.
You've added the file. You can see it here.
Yes, I can see it, but it looks as if it has been added to the Python files. I mean the content.
I'm not really getting you. Is the file
Can I share
showing
my
here?
screen?
Okay, let me just pause a little and share your screen. Let me see what you are trying to see.
Yeah.
Okay.
Okay, can you see my screen? Please, can you see my screen?
Yes, I can. Okay, so click on the file. Click on the file. Let me see. The one by the side.
Okay, this one.
Click on it. Let me see. Okay. Yes, yes, yes. I'm sure you have opened some plenty stuff. Where should it? Go to the click on the content. Let me see. There's content up there. Yes. So make sure the file is, you come and place it inside here rather. Right? Put the
Okay.
file inside, yes, copy it. Or you can go to the content side. Go to the content side rather. Upload. I hope it will not enter inside the just click in the
Okay.
on the surface inside there. It has come there. But it seems you have put
Yes, yes.
standard put it down. It's not inside contents. So click on
Oh,
contents rather. Go to contents. Click on content
I'm
and
under the
upload.
content.
Yes, click on it.
Okay, it's under the sample. It's under the sample data. This is where it is.
It should not be there. It should be inside the contents. Right?
Oh, okay. Okay. This way.
You seem to still have it under sample.
No, no, it's now under content. It's here.
Okay. And then
It is now under the content, please.
it's under the content. Okay. Then have you seen the name? The
Yes.
name is manufacturing underscore datasets,
Data
right?
set, yes.
Yeah, but you wrote only manufacturing, so that's why all the errors are coming. So try and resolve it that way. Make sure the name is exactly as it is, underscore
Okay.
datasets.
Okay, okay, okay.
Yes, yes.
Okay.
You can also go to your file and then rather rename the file as manufacturing, rather use it as that. Yes, you are still having the error because I'm sure you are still having the this one under the files, or it's not under the files.
No, it is not
Sorry,
under
under
the file. I've removed it.
it seems
Here,
to
I
be
have
under
removed
the.
it.
You have removed it. Okay.
Yes, yes.
Let me see what is the reason. Manufacturing data set.csv. Okay, let me see your issue.
Okay, okay. It's saying PD is not defined.
Yeah, so go up your library. You have to import pandas as P device there.
Yes,
Import
that is here.
pandas as PD. What could be your
Do I
issue?
need to run this?
Yes, yes, yes. You need to run because if you not run it, you see, you
Good.
need to take.
Okay.
Yeah, so you can now come and run. You are fine now. and final.
Okay.
So all the best.
Okay.
Thank you.
It's a code block. So you need to run your code block before you follow through. This is Google Colab. Don't
One. Yeah, that's it.
Okay.
So,
Thank
as
you.
I said, the code block, you need to run from top. Anytime you jump one, you come. So that's why it's not seeing the pandas that you have actually imported it yet. Okay.
Okay. Thank you.
So, yes. Let's go now to, we want to split into training sets, S train, S tests, Y train.
Please, sorry, you may need to share your screen again.
Okay.
Share.
Okay. Let me do that now. Okay, so we want to split into S train and X test, right? So you call all of them, because one nice thing about this train test split is it will do all the work for you. So all that you need to do is to narrate the things you need. You need S train, comma, X test, right? And then you want also to have the Y train and Y test. So what you mean that to pick the S train corresponding to the Y train, and then the X test corresponding to the Y test, right? Good. So let me just use the head data to show. So let's say if your training data is between from 0, 1 to, what you mean that it will pick all the data here as the S train, and then to pick the corresponding one here as the Y train. Then here, this part, all the ones here will be taken as the X tests, and then the last two here to be taken as the Y test. So that's the nice thing about using this train test splits. So when you do that, you call that, you say train test split, then you put into brackets. So which data are you splitting? You're splitting X, so you say X comma Y. Now, one nice thing about this train test splits by scikit-learn is that you have something we call test size, right? So you state test size, and then you state how much of the data that you want to use for testing. Let's say you want to use 30%, 70% for training, 30% for testing. And one thing about train test split is you don't need to specify the training amount. When you specify the test size, it will automatically know which training quantity you need, right? So let's say we want to use 30%. So I want to make it 0.3, that's 30%, right? So you just say X, Y, comma, Y, then you specify the test set, the test size, and it will automatically get to know that 70% of the data should be used for training. Now, one thing is that we mostly in machine learning add this something we call random states here, random state. And this random state is just to make sure that, the data that you have, we have about 10,000 data sets. Anytime you run the code, the Python will take 70% of the data. Now, 70% doesn't mean it will take the first 70%. It will randomly pick any of the rows, right? Any of the rows, 70% of that. So let's say if you have 10,000 data sets, to not pick 70,000 from 1 to 70,000 to 7,000. It will rather pick randomly 70% of the data. So most of the time, if you just don't want, one thing is that if you don't bring the random state, anytime you run the code, you get different results because it will pick different 70% every time, and then it will try to do the random. So mostly bring this random state and you give it any number, right? Give it any number. So most of the time in machine learning, in computers, I use this number 42. But I can use 1, 0, 1, 2, 3, any number. But I learned some people were wanted to know whether God exists or not. So they were programming to know whether God exists. And after their programming, the answer that came out was 42. And they didn't know what is 42. So it's a random number that just appeared when people were doing their research. So it's just a normal number, popular number being used. But I can use any number, right? Good. So you run, and then good, everything is fine. It means that you have splitted your data into training, into testing. So the next thing we want to do, let's add another code cell, is to scale our data, right? Let's scale the data. So if you know your machine learning process, you know the next thing you have to do. So scaling your data, what you need to do is that you want to take so first of all, you need to call the scalar, right? So let me say scalar is equal to, we call this standard scalar, right? So we want to use this standard scalar to do the scaling for us automatically. But I just want to And most of the time when you call a function like that, you just bring this bracket to say that you're calling the thing, right? Otherwise to give you error. So we want to put the standard scalar and call it scalar so that we use this scalar to do the scaling, right? So the next thing we will do is that the training data, let's call it, we can decide to call it S-train, right? So let's call it S-train underscore scaled so that we know that the training data, we have scaled it now. Let's call it underscore scale. So this S-train, I want to scale it. I'm just calling it, just giving it another name. But you could also leave it as S-train still. Then because you have called a standard scalar as scalar, you just say scalar dot, then use this function called fit transform. So that's what is going to take the S-train, into bracket the S-train. It's going to take the S-train data and it will fit transform it by scaling it down. And most of the time, this standard scalar, we have something called min max scaling and all that. We have log normal scaling. We have different scaling process, right? And just that for normal machine learning work, you just use your standard scalar and you are good. So use this fit transform. So what this fit transform does is that it will look at the S-train data and look at what is the minimum value, what's the maximum value, and then use it to divide all the data like that so that they all be between 0 and 1, right? So you need to also take the Y-train data, right? You need to take the Y-train data and also scale that one, right? And also scale that one. Good. Not every time what the suggestion, take them. Good. So Y-train dot scaled, we are going to use the scalar to now, most of the time, if you use fit transform, now one thing I always say is that we don't need to, most of the time, you don't need to scale your Y data, right? You don't need to scale your Y data because your Y data is either 0 or 1. So just leave them as that. So we have scaled the X data. Let's scale we have scaled the training data. Let's scale the test data, right? Let's scale the test data. S underscore S test underscore scaled equals to do scalar dots. Now you see, most of the time we use fit transform. The one you are scaling first, use fit transform because the fit there lets the standard scalar check for what is the minimum, the maximum, and all that. But the thing is that if you have already checked for the minimum and maximum and all that you need to just when you are scaling the test data, all that you need to do is to just transform it because the fits from the first one have already determined all those parameters from the data already. So you don't need to use fit transform again when you are scaling the test data. So we just use transform and say S underscore tests. That's good. So every time it's your features that you want to scale and just leave your Y data. If you want to scale the Y data, you can do that, but you have to go through a long process of reverting them and all those things, which we don't want to go through, especially with this work. Good. So now we've scaled our data. Let's run that to see all our scaling is good. Let's go to the next line. And then now we want to let's call all the 3 models we want to use, right? So let's call our models, all the models we want to use. So let's say we have KNN. We say we want to use KNN. So let's call, because we don't want to use this K nearest neighbor classifier, let's use this K nearest neighbor classifier. We just want to call it KNN, right? So let's say KNN is equal to, then I'll call this KNN classifier. Then I'll just bring this bracket, right? Good. So let's say that this K nearest neighbor classifier, we want to call it KNN, right? And the same way, let's take this. We are going to call this decision tree classifier. We are going to call it DT. And the random forest classifier, can call it RF. And this name, you can change it. Any name that you want to give it, you can give it any name, right? So you can say K nearest neighbor should be K neighbor. Decision tree should be decision. Random forest, I just use a short name and all that. Good. So we've called all the classifiers that we want to do. And this code, I'm just going with it step by step. But as you go on with Python and get to know how to write for loops and all those things, you can call a model and put all these classifiers within the model so that every time you can use the model to do the work. But I just want us to go step by step that anyone can easily follow. So we've just called all the classifiers and giving them a name. So now we are going to use the classifier to fit the model because we have scaled our data. So we need to fit the classifier. We need to do the classification work, right? So let's go to the next cell. So here we just called our model. The next thing is that we just want to train, want to go through the training process, train the models, right? So we want to do the training process. Let me bring my hash, what's the comments? So we want to do our training. And with this, what I want to do is that I want to use KNN to do the training. I'll use decision tree to do the training. I'll use random forest to do the training. Now, one reason why, here, this work, maybe we could have just used only K nearest neighbor to do the training because you don't need a lot of models. But the reason why anytime you are conducting a machine learning work, you use a lot of models is that you need to know some models do better than others, right? And from the beginning of the data, you will not be able to see that whether K nearest neighbor will understand the data better than decision tree or better than random forest. So one thing that you mostly do is to test all the models. So that's why you need to get to know plenty of the models. You test all of them to see which of them really understand the data very well. Because there are some data that a decision tree will be able to understand it better than random forest would do. Sometimes random forest would understand it better. Sometimes XGBoost will understand it better. So you need to always deal with a lot of models. So here I'm just using 3 models. By your assignment, you use 5 different models. And I'll just open you up to any 2 additional models you want to add. If you want to add logistic regression, you want to add support vector machine, you want to add XGBoost, other boost, any of the gradient boosting algorithms to it, you can do that, right? Good. So let's just fit these 3 models now. So, sklearn has already programmed how this class, remember when we did decision tree and you have to split this one, we have to have the leaf node, the root node, then we split using the Gini importance and all those things. One nice thing is that sklearn have programmed all this thing inside this decision tree classifier. So you don't need to know Gini importance, splits by this, calculate this, and decide how many are this. After that, do voting, and all these long processes have already been done within this decision tree classifier. So all that you need to do is just to call this decision tree classifier and use it for the training, and then it will do the work for you. So let's say you call this KNN, then say KNN.fits. You say KNN.fits. So now you just want to do the training. So just use this function fits, right? So just say, I'm calling this classifier. This classifier, I've now called it KNN. So I just say KNN.fits. I put into brackets. And how is it going to do the fitting? It's going to, so we said that what happened during the training? You show the X, then you show the Y, corresponding Y. You show the X, you show the corresponding Y. So now we are using the S train scaled, right? We are using the scaled data. So S train scaled, Y train. So what it means is that when you write this line, what will happen is that line by line, every feature will be shown to the KNN and the corresponding Y value, whether it failed or a pass will be shown to it, and it will do this automatically with this fit function in there. Then we go on to the next model, the decision tree. We can also fit that one using the same S train. So this thing is just a repetition, just that we are using different models, right? If you are using only one model, we would have just used one model and then with KNN.fit, you are done. Those who are new to coding and all that, you can always have only one model. And all that you need to do is the next time you want to test another model, you go to the code and just change it from KNN and then use decision tree. And then the next one, but that one would, coding is just to help us to do one thing at a go, right? So that one will let you record your data one by one by yourself. But I want to just let the coding do it automatically for us. Then we'll do the same thing for random forest. So we take the S train and we the skilled one, and then we give the Y values corresponding ones. Good. So this will do all the training, right? All the training. So after the training, the model will be able to understand that anytime the S train is like this, anytime the speed of the machine and the temperature is like this, and then the quality score is like this, and all the features that we have are there. Let's look at some of the machine and how much energy is consuming. You know this very to not fail, right? To not fail. You know, all these things will help you, especially when you want to choose some very good temperature, machine speed, and all that, that you can always operate your CNC machine so that you not be failing with respect to your drilling and everything. That's just the importance of machine learning. So we have done all the training. So the next thing we need to do is something we call prediction. Prediction, right? We need to predict or test the model, right? We have trained the model. So we want to test whether the model is doing well or it's not doing well. Let's run and see whether we have fit well. So it will be running, and then it will run random forest, run this and run that, and then you have that. So we have done the training. Let's now test. Hash testing. So with testing, we already have, let's call our prediction, let's say for the KNN, let's say KNN underscore predict. When we make the prediction, we want to put it inside this thing, right? So we want to say KNN. So you see, we have fit the model. It means that the KNN now understands everything about training and the test. So we just have to pick the KNN, right? You pick the KNN and say use the fitted model and say dot predict. Then you give it the X. So here you are giving it only the X, not the Y. So when you give it all the X, it will predict the corresponding Y. To predict the corresponding Y. So when we finish predicting the corresponding, what we do is that we now go and compare it with the original Y to see what we predicted. Is it the same as the original Y that we predicted or not? That's fine. So when I do the prediction, I want to put it inside this KNN underscore predict. So the same way so this is for the KNN. Let's do for the decision tree. So let's call it DT underscore predict. So that one to say DT dot predict, the decision tree dot predict. Then we give it the test data. Do the same for the random forest. Then we say RF. Now, depending on the name you gave it, right? Here, you see, we call random forest RF. Maybe you call your own rand F. So make sure you use the same name. Otherwise, you will not be able to do the prediction because the model you are calling is the one coming to do the prediction. So when you do this, everything will be predicted and be stored inside this. And all that you need to do is to just go to the data and compare it with the original data there, whether it corresponds to what is there, right? So maybe depending on the test data that came, the model says it will fail. But when you check the original data, it didn't fail. That means that it has made a mistake. There's an error there. Then it will check another one, it said it will fail. Then it showed that it will really fail. So to automatically do that, when you say dot predict, to do for all the 30% data sets that you left behind for testing, right? And at this stage, you are totally done with the machine learning because you are done. All that you need to do is to go and start plotting or start showing your metrics to show whether so let's run so that whilst I'm talking, it has even done it so fast because we don't have much to do here. Good. So this will do all the prediction and store it inside there. So all that we need to do is, and the thing is that if you have 10,000 data, you can't go in one by one to go and see each of the one that you predicted, whether it's the same or not. So you just have to use a simple code to help you. So let's go to our metrics. So the metrics will check each of them and check to see whether what you predicted was the same as what you needed. Good. So let's let's print the accuracy, right? Did we call for, hey, who is writing on my screen? Okay, so we call for this accuracy score. So let's use it as the first metric we want to do. So let's do the accuracy score. The accuracy score for so let's do the accuracy score for KNN. So what that we are going to say is it's just going to check the accuracy. So we just call accuracy score and say the Y test. This is the original data, the Y test from the main data. And this KNN predict is what you predicted. So what it means that you check what you predicted against the original the test data. When it finished that, it should print it on the screen, right? So use print into bracket the accuracy score. Print into bracket the accuracy score. Good one. Then you do the same for we've done for KNN. We do the same for random forest. Is there any comments, any questions so far? From the comment section and all.
Yes, so you can check and go through it and see which one you want to answer.
Okay, good. Good. Now here, I don't want to give it a name accuracy score because when I do that, because I'm going to do it for KNN and everything. So let me just say accuracy score is this, right? So that when I just say print accuracy score, only the accuracy score will just will show, right? I'm sure I'm using this one to be able to just show it for me without even trying to print. Let me see. Good. So this one will show it for me without the need for trying to write print. So that's one nice thing about using Colab or Jupyter Notebook. You don't most of the time say print. When you run, you may run them. So the next thing is let's do the accuracy score for the decision tree and the random forest, right? So here I say Y test decision tree predicts because you see here is for KNN predict. Yeah, this is the predictions, and then the Y test one are the original data, right? So that's that. Let's rerun that, and then it will show. I'm sure it's showing the last thing. Okay, so it will show the last predicted one. Maybe I would want to show it one by one. Let me just go and answer the questions first. And let's see what. Please, can you explain how you identify the range of features and the targets? Okay, so I was saying that for you to know the columns for your features and your targets, you should know what do you want to do. I want to predict whether my machine, at the end of the day, the drilling I'm doing, I want to check whether it will fail or not fail. So the idea of fail and not fail is telling me I'm doing classification. But then which one will be my target? I have to look in the data and look for the column that shows fail or not fail. And I know that automatically becomes my target. Now that I know the target, I have to know, and most of the time, the rest of the data is the features, right? But most of the time, not everything that will be the features. But just this example, everything is just the feature because the features just looking at what are the things that you want to use to determine whether the thing will fail or not. You want to use temperature? Do you want to use the speed of the machine, the energy consumption of the machine, and everything? So then you know that all those ones should be your features. So that's how you get to know. The thing is, most of the time, when you get to identify your targets, you automatically get to know what your features are going to be. Okay, so somebody was showing the manufacturing data set. Can the attendance, okay, this one, why is 42 common? I think I explained why we mostly use 42. You can use any other number. Not look like training. It means showing some steps. Okay, I don't know what he was answering to. Can you use just one or two classifiers? Yes, you can use one or two or more than three. As I said, the assignment, you add two more classifiers as that. can we define the accuracy score for each model and then print each one's score differently? Yes, so that's what you want to do. That's what you want to do. That's what we want to do now. Okay, so I think we have all the questions answered now. So let's try to do that. So let me just try to do this so that we can say print. Let's try to print and just say KNN accuracy. Right? KNN accuracy. So let me put this, and I want to, you see this is a string, so I just want to put some colons here so that it will print each of them separately, right? So here I just want to say print, and this is words. I just want this word to come, so that's why I'm using the colons, right? That the apostrophe or something, colons. Oh, it's not colon, it's just what's in the name? Colors. Yeah, so KNN accuracy, then say accuracy score, y test KNN this. So I just want to do the same for each of them. Let me do this. Do I have underlined? Okay, I need another bracket. Good. So I want to do the same for here. I just want to do decision tree accuracy.
Doctor, your this thing is wrong. Your syntax is wrong. You need to bring comma instead of the column.
Come again?
You need to bring comma after the KNN accuracy. The first line, the print.
Yes.
Bring the column after the accuracy, and then bring comma after the double quotation.
Okay, I get what you are saying. As in the comma here.
Very good.
Okay.
No.
Thank you.
Send the column into the
The
double
quotation
quotation.
come after the colon, right?
Yes.
So that it won't come as well.
Good. Very good.
Good one. Good one. Good one.
So this is a
Thank you for
syntax
that.
error.
Good. So that everything will come as words, so that the colon will also come as words. Then the rest will calculate, right? So let's do. So this one is say random forest accuracy. Okay. They need to bring all these accuracy scores. I hope you are all following. Good. We did fine. Let's run that. Hey, what's going on? It said this. Okay. I think I need another bracket. I need another bracket. Yeah. Let me see what's the issue. The y true parameter of accuracy score must be an array likewise pass this tree accuracy this. Let me see what's going on here. Okay, all of them I print is not print, that's why. Prints.
Yes, good. You only printed the first one.
Good one. So we realize that the decision tree is giving us 100% accuracy. Random forest is giving us 100 because this data is just a simple data, but you have some this data is actually just to start understanding how smart manufacturing and everything is going to be. But in real life, you get some data that is very stubborn, you'll not be getting 100% accuracy. So you realize KNN is not really understanding the data very well. You introduce other models and you realize that some of those models will also not be able to understand the accuracies very well. So these are the accuracies. But most of the time, what I want to do is mostly to print the something we call the classification report, right? So that one, you don't need to do the accuracy one by one like that. So I like that one, classification reports. Classification reports. So that one, all that you need to do is just to say print. And here I just want to print the KNN report alone. Okay, let me just print because which one should I print? I just want to print one of them so that your assignment, you will print all the others, right? So you print the classification report for, which one should I do? Maybe for random forest, right? So let's print for random forest. Let me change it to random forest classification reports. Right? And all that I'm going to say is y-test. Good. So I'm just going to do the classification report y-test for only random forests, right? When you get your this one, print the classification report for KNN. I think we'll define the assignment. So you print for KNN, print for that of decision tree also. So let me just do for random forest for this one that we are running. So let me run that. A nice one. It gives you the accuracy, the final accuracy. It gives you oh, my report is not looking nice. Let me just print classification. Let me not just leave it plain name. See if it has moved. Let me just print this so that it will look nice. Yes. So that you know here is the precision. This column is the precision. This one is the recall. This one is the F1 score. And this for random forest. And it's doing a very good prediction because it's giving us 100% F1 score, recall, precision. But this data is just a simple data and it's able to understand everything. If you can go and read about this macro average and the weighted average of the classification report. But mainly you just need the precision, the recall, which we spoke about when we were dealing with metrics, evaluation metrics. So when you go, we'll define the assignment, also go and print for K nearest neighbor. We also do the same thing for decision tree, right? Now let's also plot the confusion matrix. Let's plot the confusion matrix for right? And I just want to do for random forest here. Yeah, to let me define that. I just did for only random forest. So you will do for the others, right? Only random forests. Good. So here too, all that you need to do is just say CM, let's call it confusion matrix. Let's call it this. And here we are plotting. Good. So here, this confusion matrix, we want to say y-test. You want to say y-test and then for random forest. And here, so I'm just printing the confusion matrix for only random forest. When you go home, the assignment you do for random forest for K nearest neighbor and everything so that you can compare to see which one is doing good work or not doing good work. Now, one thing is that when you just print this, you are going to have it like this, right? You know, when I click run, it has run, the results is not really showing on the screen, right? Good. So most of the time, this confusion matrix, we'd want to plot it as a heat map, right? And then we use this that Seaborn library I spoke to you about. And then you say SNS, you use this mostly for heat map. Just say dot heat map. Then you call this CM. And then you make the annotation true. And when you run that, you are going to get your confusion matrix nicely plotted. Nicely plotted. So the plus 0.3 is just saying that out 2,700 of them were predicted correctly. And we all know how to read confusion metrics because we read that. And random forest giving 100% accuracy, just showing that all the ones that failed, it predicted all of them correct, and all of them that were that passed, it also predicted all of them correct, and all of didn't miss any of them, right? You can go when you go, you plot for KNN, you realize that KNN missed some of them. The scene tree actually also predicted all of them correct, and basically that is all we want to do for today, just for you to understand the. Now, one thing is that most of the time, maybe your should you even add that? Maybe you want to show which one is. Maybe you want to put a title on this thing, right? You just say just have to use the matplotlib, right? The matplotlib. We just said that we are going to import it as PLT. So what that you do is that you say plot.title, right? Maybe you want to just put a title under this, and we just want to say, call it confusion metrics. So you want to also, maybe I'll come to this. So let's run that, and then you see that the title will come on top. Have you seen the title is come? This just some things you just have to learn one by one on how to put a title and put an X label and then put a Y label and all those things, right? So PLT, X label, we want to show that the X label is the predicted ones, and then the Y label is the actual ones, and you can decide not to show by itself. Good. So I just want to say that this part is the predicted one, and this part is the actual data, right? So let's run that. And these are just ways so that the actual will appear here and the predicted, depending on how you spell it, can bold in it, and all those things those are all gymnastics you learn around Python just to see your drawings nice. Thank you very much. And I'm sure you have followed me line by line. And this is just a way to run a machine learning work. Now, when you finish everything and you get to know that, oh, random forest, the one that understands the data, that's when you want to use random forest for the model that you want to do. So basically, that is all from my end today. And I'm sure I've not used too much time, 1 hour, 30 minutes flat. Can we define the accuracy score for each model? We've looked at that. Please, could you drop the manufacturing data link or file? Okay, so it will be dropped. Is it metrics or metrics? Okay, let me check my spelling. Those are just, and you see, because I commented that out, I'm not sure it had, okay, I use metrics, like meter. Good. The next question is metrics. Okay, somebody answered it. It's metrics. Okay, so thank you very much. Any question for me? So all that we are going to do is that we are going to give you the data. I'm not going to send you this code that I just did. All that we are going to do is the video will be available. Just watch the video, follow the process of the video, go through the typing yourself one by one. I think throughout we just be sending you the code. This is just a project, right? Go through the typing one by one. And I think after everything, I'm just going to narrate the assignment line by line, right? So that you know what you have to do. And that's what we will check to see whether you have done the right thing. As I said, here we are not trying to, it's not any school exams, right? We just want to let know that all the things that we have taught, you're able to follow the pipeline of the machine learning, that this time I have to split, this time I have to import, that I have to split, I have to scale, I have to train, I have to predict. Then after that, I compare, and I know the metrics that I'm looking at, whether I am going to do classification, because I'm doing classification, I'm going to use confusion metrics. Remember that if you are doing regression, we have metrics like the mean square error, the R square. You realize that I've not done any R square inside here, right? Because that will be used when you are doing a regression work. R square, mean square error, root mean square error. Realize that all those metrics, I've not used them here because I'm dealing with classification, right? If Dr. Tabiri will permit me the assignment, I will add that just go through this same data set and rather change everything from classification to regression, right? And basically, I'm just going to follow the same process.
Dr. Harris.
Yes, sir.
What you have done is confusing enough. Just
It's confusing enough.
yes.
Okay.
So don't let people change things.
Yeah. Okay.
Let
Good.
us
Good. Thank you.
replicate this, and then I'm trying to follow you, but all my code was full of errors. So
Okay, but we can start correcting some within just some 10 minutes so that
no,
we
no, no.
all
I'm okay. I'll go back to the
okay.
video and see what was wrong. But
Exactly. I think that's the import of the assignment we want to give them
mhm.
so that they go through the video and correct anything that they need to correct. Okay, thank you very much. I like tough exams every time. That's why. And Dr. Tabi doesn't want to allow me. Good one. So let's go through the same classification work. And I want you to go and look for two classifiers so that you all not do copy work, right? Just look for two classifiers yourself. You can go for SG Boost. One thing about SG Boost is that it's already not inside this Google Colab. So you may need to do something called pip install. Then you can pip install this. I think SG Boost should be around. I think other Boost is the one that's not available. SG Boost should be there. I want you to use two more classifiers, and I'll send the assignment, right? So, but let me just narrate them. Two more classifiers, and as I said here, I just printed the report for only random forest. So you are going to print the report for all the five models that you are going to use, right? You're going to use print for KNN, for decision tree, for random for which I've done already. You're going to do, if you use XGBoost, you also print the report for that one. And what you're also going to do is you realize that the confusion matrix I printed for only random forest. So you're also going to print for decision tree, K nearest neighbor, and the two, maybe if you want to use logistic regression and all that, and the two additional classifiers, you're going to also print them, and then you see all the confusion metrics displayed down here for me, right? So basically, that's all, and we'll go through each of you to see. There's no need for copied work. Don't let somebody send his work to you to look at. It's good that I'm sure we are dispersed in Africa, so most of us are around anywhere. I'm sure most of us don't have our numbers and all that. So just try to go through this yourself because the video is there. Just go through yourself. When you are making mistakes and everything, just go through the video and see the line very well and just replicate everything. And through the process, try to learn, right? Don't just try to replicate. Just try to know what is happening there, and then you'll be good. Good one. Any question, then we close.
Yes, so I want you to clarify the submission. Do you need a code, or they should
Yes.
save a file here and send it to you? Wow.
Yes. So the submission, I need you to zip everything as one file, right? So you zip everything as one file. Then you put in the code, right? Just put in the code. I think basically the code because I already have the data that we are all using the same data set. So I mean I can even just share the code, only the code, right? Just share only the code. And if you want to, I think for sending purposes, most of the time, sometimes you are sending that via mail and all that. Just zip it and name it with the name that, or should they use their IDs or their names? Their names are fine, right?
Both. So the names can be the same, so the code will be something that will distinguish them. So
Good. So just save the thing with your name, right? So here, let's say if your name is Kofi, just save your project as Kofi dot that
you
and
can
share.
just
You can use
put your email
Twitter
there if you don't
notebook.
have
You
your
can use
code.
Visual Studio Code. Yes. Please come again. Yeah, Sylvester, I can't hear you.
Yeah. Uh, can I run this on a Python instead of Google Colab?
Yes. So for Python, you not run it in Python itself. You have to use Google Colab or Visual Studio Code, or you have to use Jupyter Notebook, the one we help you install at the beginning. Is that fine?
Basically, for whatever you use, you just have to send your code in.
So whatever that you just save the file, please make sure that the file is saved as IPYNB or just .py. Those are just the only two files I need. But if you are working in Google Colab or if you're working in Google Colab or Jupyter Notebook, you have to save it as IPYNB. If you're using Visual Studio Code, you have to store it as .py, right? So that I can open it, because we want to open it and see what you have there. And when I run, I will see the plot. Make sure that you run it yourself to make sure that you don't have errors before you send it. Because when you have errors, it means that you didn't do the assignment, right? So just follow the video line by line, program everything. Even if you don't understand, when you go line by line, you'll be able to follow with the background audio and everything.
Sorry, Elvis. I think people want to know if they can use the IDE to basically write the code before. So like PyCharm and all those notebook
Yeah, so you can
editor
use
things like that.
PyCharm.
Yeah, I think that is why he
Thank
was
you.
saying if
Can
you
you
can read on Python.
Oh, okay, okay. So you can use PyCharm, you can use Google Colab, you can use Jupyter Notebook, you can use Visual Studio Code. I think these are the popular ones. If you have any other IDE, you can just go with it. So far as you just save the thing well, when I open it, it will open.
All right. So I think since you'll be the one receiving uh, the assignments, you can drop your just write your email in the code so that it will just show. So everybody that follows this video, when you get here, you just send your assignment to us. That means that your email is also going to be public. So just put, let me just put the YAS email, the YAS official email.
Okay, so please, if you have it, just send to me. Let me just put it in as part of the code here.
Yeah, I'll just
Well,
put it in the chat and then you can copy it for them.
okay, sure. That's great. Let's use the yes, and then
So please send your assignments to the YAS, and when we get them, we'll forward them to him. And then once we get your assignment, we'll send you your certificate. So I've put it in the chat. So Elvis, you can check and then just
okay,
add it as a line, a test line here.
okay. Good. Let me build in that send to this. So your mail, you should just make it engine projects dash your name. Yeah, so that will be the heading of the engine project dash your name. Then you just put the Python file inside. If submitting the Python file is an issue for you, just zip it and send the zip file.
Yeah, somebody is
Yeah.
asking if there is a deadline. There is no deadline. So whenever you give yourself time, understand what is going on, or try as much as possible to know the process. The code will always be available for you. So just know the process. Take your time. Whenever you are done, you send it in. For the certificate of participation, everybody is going to receive it by the end of this month or early next month. We'll start sending them in batches from next week. And so you will receive it in the email that you registered with. If you don't receive it, contact us with this email and say that I didn't receive it. Maybe your email you gave us is wrong. Then we can send it back to you. So just wait for a little bit to receive them. All right, Elvis, you can just wrap up and then we can close for today. If there are any questions, please let us know or put them in the chat and let's make sure you are okay.
Yeah, so
Yes. Hello,
yeah,
Dr. Tagli.
Yeah, go ahead, Henry.
Yeah. So with the project, is the project going to be individually done, or for some of us we work together here, like Gono, Mohammed and myself, we are always together. So is it possible to do it together like that? We share idea and get more concept.
So the certificate is an individual certificate. So you have to submit your assignment individually. You can work together to understand it, and you can do it on your own and then submit.
Okay. All right. Thank you.
Mm.
yes. So basically, it can be to do discussion and everything. Then everybody goes home to just write his own, right? Just to understand yourself. Somebody is asking whether you can use Python to redo everything. You can do that. So far as it's doing the work and it's following everything, you can use PyTorch or TensorFlow and all that. Just that your code is just going to be longer with more syntax, understanding, and all that. Can follow or use that. So far as it's understanding, we just want to know that when you have a certain data and you are conducting a machine learning work, you'll be able to do it by yourself. So if you understand PyTorch, you want to use that, you can also do that. So thank you all very much, and thank you for following through almost all the things we taught. And there are a lot of projects we can do, and we just want you to follow through the videos that maybe you couldn't watch and everything. Make sure you watch them. If you want to do any other projects, because this one we just did a very simple classification work. If you want to do other regression work and all that, we're actually taking you through sample examples and everything. Just go through yourself. The regression work is not part of the assignment. You can just go through the same code, change everything from classifier to regressor, and just play around, correct your mistakes, and you'll be able to do that. Then you go back to the image classification things, just see the images, follow the thing through. And I'm sure as the days goes by and then we present to you some of the conferences, then people show some of the machine learning work that they are doing. It will just boost your interest for you to continue with this young African science. So thank you for following through with us. And we are happy to have you, Dr. Tabiri. Thank you for the opportunity. Bye. You can close us now.
So thank you, everyone. So this ends our first session for machine learning course. We're going to run new courses in the coming year. If you are interested in any of the courses you want us to focus on, please send us an email and say that I'm interested in this course. Can you guys organize it for us? Then we'll look for the resource people and we'll organize it for you if there is interest. So, but for now, thank you very much, everyone. You kept coming and it's amazing. God bless you all. And I hope every knowledge that you have acquired here will be helpful in your profession and in your research. So thank you very much, everyone, for being a part of this successful course run. You'll receive your certificates in due time. God bless you all. God bless you all. Feedbacks are accepted in our WhatsApp.
When you send your assignment, we will send you a certificate. So there's no deadline. Just make sure when you send your own, we'll send you a certificate.
Yes,
thank you.
But you will receive your certificate of participation and everyone will be fine. So thank you. Thank you for being a part of this. And go to our website, theyaslinkup.com, and then our YouTube page. You have all the videos available there and you can follow up there. All right. God bless you and see you in the next program that we do. Bye-bye.
Bye.